Alrighty, let's get started. So, we'll be looking at the hyperbolic, and particularly, just the effect of A, P, and Q, because it's important to know the sort of the general form of the graph before you actually sketch the graph. So by that I mean, if say for instance you're required to sketch, say, minus 2 over x plus 1, plus 3 or whatever, you should already know how your graph should look like before even sketching this graph. Okay, and for you to know that, you need to know the effect of A, P, and Q before you even sketch the graph. Okay, so I think I'm gonna do away with that so that I don't have too many things on my screen. Okay, so currently, so let's first investigate the effect of A here. So currently my graph looks like this. It's just 1 over x, meaning the P is 0 and the Q is also 0, as you can see from my sliders there. Right, so currently my A is positive. Just see where the graph is positioned, in terms of the quadrants. So this should be, so we call this the first quadrant, second, third, and fourth. And then one thing that you also need to look at is where your asymptotes are. So the line, this line, which is the line y is equals to 0, or the x-axis, but as an equation it's y is equals to 0. So that line acts as the horizontal asymptote because my graph will never touch that line. And then this one here acts as the vertical asymptote. So x is equals to 0 acts as my vertical asymptote. And my graph is now bounded in the first and the third quadrant because my A is positive. So A is positive 1 at the moment. Now, A can be 2, 3, 4, 5, and so on, up until 8. As long as your A is positive, your graph will always be in those two quadrants, the first quadrant and the third quadrant. Okay. Now, I'll talk more about these quadrants because we are necessarily not referring to the quadrants that are formed by the x-axis and the y-axis, but I'll get to that. So, A positive, first quadrant, and the third quadrant. Now, as soon as my A becomes negative, well, obviously when your A is 0, you don't have the hyperbolic because, A over 0 is 0, so you just have 0, y is equals to 0. But as soon as your A becomes negative, you see your graph jumps to the second and the fourth quadrant. Now, positive A, first and third, negative A, second and the fourth. Okay, so I mean, in simplest terms, that's what A does. A determines the position of sort of those two pieces of the graph in terms of in which quadrants will the two pieces be positioned. Okay, so I'm gonna keep A to be, well, let's make it 2, and then maybe play around with, or let's play around with P. Currently my P is 0, and if P is 0, remember we have this as the graph. Okay, so currently my P is 0. I'm gonna play around with the value of P. Now if P becomes 1 or 2 for that matter, so let's just make it 2. So can I still say my graph is in the first and the third quadrant? Actually yes, but my asymptote has now shifted. So that asymptote that was at x is equals to 0, it is now at x is equals to 2 because my graph has shifted 2 units to the right. But in terms of quadrants, my graph is still in the first and the third quadrant. Now by quadrants, we are referring to quadrants that are formed by the asymptotes. not the quadrants that are formed by the x-axis and the y-axis. So you need to just bear that in mind, that by quadrants it is in reference to the quadrants that are formed by our asymptotes. So if p is 3, okay, can make it 5. If p is 5, you see your graph is still in the first quadrant and the third. These are quadrants that are formed by the asymptotes. Then if you play around with your q, maybe say, let's make it 2 for instance. You see, this is now my first quadrant, my second quadrant, my third, and my fourth. A is still positive, the graph is in the first and the third. But now my horizontal asymptote is now at y is equals to 2, and the vertical asymptote still at 5. I can place it at 6. This is what you'll have. And I mean, your p can be negative. It will only mean your graph shifted 4 units to the left in that case, and this is your graph. In terms of quadrants, your graph is still bounded between the first and the third quadrant. I mean, you can play around with the value of a and make it negative. You see, still now it's in the second and the fourth quadrant, the quadrants that are formed by our asymptotes. Okay, and your q can be negative as well. It can be down there. So your a is negative, the graph is in the second and the fourth quadrant, and our horizontal asymptote is now at y is equals to -4. P can be 1 or 2 for that matter. So the reason why we have an asymptote, actually, an asymptote basically, it's where the graph is not defined. So this means for x equals to 2, you won't have the corresponding y value, because if you plug in 2 there, you'll have 2 minus 2 down here, and 2 minus 2 is 0, and anything divided by 0 is undefined. So x value of 2 does not have corresponding y value. That's why we say x is not in the domain of the graph. Similarly, with y, with the horizontal asymptote of -4, if y is -4, you won't be able to solve for x. And for the sake of time, I'm just going to say this. If, say for instance, you take y of -4 and say -4 is equals to -6 over x minus 2 minus 4, and maybe say you try to solve for x from this. Obviously you'll transpose the 4, so we can do that quickly. Transpose the 4, you'll have 4 minus 4 that side, which will be 0. So this will be -6 over x minus 2. If you multiply both sides by x minus 2, 0 times the x minus 2 will be 0, so you'll end up with, so this will cancel out that, you'll end up with 0 is equals to -6, and 0 is definitely not the same as -6. Okay, so the point is, there's no corresponding x when y is -4, so y is not in the range of the graph. That's why we have that horizontal line there to say there's no corresponding x value, so we call that an asymptote. Okay, so that's basically that. So I'm just gonna leave it here.